interest in modelling, as I'm sure we all know, occasionally we don't quite get the hearing that we feel we should. So, to say a little about me, in case we haven't met. So my name's Herb Daly. I work at the University of Bedfordshire. My description would read lecturer, modeller, researcher, particularly because those have been my previous job titles in chronological order, and I do a lot of my research work at the Centre for Research in Distributed Technologies. So all kinds of things, all kinds of networked applications, development, performance and capacity. That's the kind of things that we're interested in at the University of Bedfordshire. The genesis of this talk, conversations that I've had with people at previous CMG conferences. Go to the May one. We tend to stay up very late and get into long conversations about what happens and what doesn't happen, and why it happens, and what should happen. And some themes tend to emerge, and we'll often say to each other, "Oh yeah, you should do a talk about that. That sounds like something people would be interested in." So this is where the idea comes from. So it's not just performance and capacity modelers who have this interest in being heard, in actually being influential. But I'd like to talk something about why the work that we do maybe doesn't get the hearing that it deserves, and how to avoid being in that situation. So, a modest aim. We'll see how we do. So just to establish what I'm talking about, typically, and this is a method agnostic presentation. So whether we're talking about analytical methods, whether you're doing some statistical work on your logs, on your network traffic, whether you're just making some spreadsheets for application sizing, we've got a system and we're looking at it and we're trying to create some estimates about what the system is going to do, how it's going to behave, what the characteristics are. So we might be interested in specific performance issues, maybe for applications or particular pieces of architecture. We may want to look at thresholds, resources. We might be more broadly interested in patterns of growth. How's the traffic developing? How many people are visiting our websites? What kind of storage we should have? When might we be interested in upgrading a disk, a SAN? So all these things. What type of things do we talk about when we talk about the problems with modelling? Well, you'll hear a lot and you'll see a lot about how we get better data for our network pieces, or how we get better data for what users are actually doing, or collect data from all sources. We talk a lot about, especially if you read the academic literature, lots of sigmas, lots of integrals, more sophisticated techniques which could supposedly tell us more about what's actually going on. You get thick books full of mathematical notation, very, very popular if you're in academia. The problem people often have in industry is how to get access to the resources that will let us A, collect that kind of data, and B, run those kinds of algorithms, because they generally are quite expensive. The other practical thing that we tend to think about is, how do we know that we're comparing apples with apples? How do we know that we're comparing like with like? And that's kind of one of the main things that tends to drive the literature on models and problems with modelling. I'd like to talk today about what we don't say so openly. The fact that very often we'll do a piece of modelling work and no one's listening. Yeah? So we'll produce some results and it's hard to actually bring them to the table. It's hard to actually influence decisions with them. If you're a modeler, typically you're in a minority of one or two, and sometimes what you're doing seems to other people to be irrelevant, especially when you're trying to get some of their time to answer some questions, or when you're trying to put forward a point of view based on what you've learned about the system. And moreover, the value of what we're doing is sometimes in doubt within the project. So people, I've been in situations where, you know, I've got a result looking to scale up one system to another. I say, well, look, okay, I've got these results in the model. I think this might be a problem. And they say, well, okay, but that's just the model. Shouldn't we just try it? Okay, well, shouldn't you? No. There's a mismatch there. So, what's going on? So this is what I'm going to try to address. I've seen projects that are very influential. I've seen projects that aren't so influential, and I'd like to share with you my observations on the best parts of the ones that actually do make a difference, and avoiding the traps that mean that we don't. So, in my opinion, the best insight is a shared insight, right? Unless we're actually influencing people, unless somebody's listening to us, what are we actually doing? Now, this problem is not just a performance and capacity thing. Modelling in general, and there are many disciplines that are interested in models, economics, operations, research, engineering types of models. Lots of places where these issues come up. So I've had a look at a range of literature to see, well, what kind of things do people say, drawn on the experiences of people that I've spoken to, and try to put together a kind of a look at how we can manage the problem. So we know intrinsically from our own experience that when we do it well, performance and capacity modelling can be quite influential. So what I have to say is organised around this acronym, which is only slightly contrived. It is the CLEAR acronym. Sounds promising, no? So, commitment, liaison, education, alignment, and realism. So, to my mind, these are the 5 principles of effective modelling. Now, I know what some of you are thinking at this point. Beware the duck-billed platitudes. For those of you who are non-native speakers, this is a slight play on words. Beware of truisms that mean nothing. So, I'm going to try very hard indeed to avoid the duck-billed platitudes. I'm very keen for you to help me do this and force me to give you concrete examples and not just say, you know, motherhood and apple pie. I will try and back these up with solutions and examples as we go along. Okay, let's talk about the first one. So, commitment, a popular misconception. So, they've agreed to have a model on this project, so they must be committed to modelling. I have sometimes felt like that. You are employed, you think, well, okay, they've employed me, they want me to make a model, of course, they're going to want to hear what it says, it's costing them this much money. Sadly, this is often not the case. Only modellers are committed to modelling. Other people, we can make them commit to reasoned estimates and reduced risks, and unless they're feeling that, unless they're feeling reasoned estimates and reduced risks, they aren't committed to anything, is the truth. So, the principle says the project is committed to modelling when the key people on the project want to know what the model says. up until then the project is not committed to anything. Yeah? Who are the key people? Project manager, people who have an interest in will this complete to spec and to time. The system architects, the people who know the structure of it and have a clear idea, an overview of how it should work. Very key person, the client, the person who is accepting the system as it is, or who's paying the bills. So if you can interest these people in what the model says, in those estimates, and in the idea that you are reducing the risk for project manager, systems architect, reducing the risk for the client, then the project will in effect be committed to modelling. How do we do this? Send them regular updates of good quality work that's coming out of the model. Let them know what's going on and what they can expect. Use the model to answer their what-if questions. So I'm going to talk in a second about how these what-if questions might evolve, but before we get there, where do these good quality estimates come from? We did qualify it. Good quality estimates. Well, this brings us on to liaison. So we have another popular misconception. Good quality estimates come from the modeler heroically interpreting the behaviour of the system. We get given these piles of documents, we create this glorious model in a room somewhere, and magically out come the results. Well, again, I say to you, I'm sure modelers among us, we know it in our hearts of hearts, this is a misconception, this is not true. The people who understand the system best at a fundamental level are not the modelers. We understand about modelling pretty well. We have generally an experiential kind of view of systems and how they behave and the problems they get into. The architects and the project managers, they have a fear of things going wrong, but the people who know what might go wrong and know how things actually work are the people who actually design the system, who test it, who implement it, and who operate it all the time. So if we want to understand how the system works in order to model it, we have to engage with these people. So this is our liaison. We've got agreement at the top, and we've got our liaison with the people who best understand the system. So principle 2, use their knowledge to help you refine the model itself and identify all the critical issues that might come into play. Now, I know what you're thinking. How exactly do we do that? Well, we capture what we know about the system. We still look at the documents, we still do our tests and run our scripts, but then we talk to them and we refine what we know based on what they can tell us. So these people, this is not their main job. So we're drawing them in, we're interesting them in what they do, and it's often not so easy to find the payoff for them. But nonetheless, I hope I can convince you, or you can convince them, there is indeed a payoff. If they don't know what you're doing, or worse still, they think they know better than you what you're doing, the engagement, the actual talking to them, is quite a full process. So, supporting the liaison, and indeed the commitment, there is an education imperative that we have as modelers. So, we may often get thrown into a situation or be hired by a manager who says, make me a model. Yeah, you know about modelling, I don't, nobody else does, you're the expert.